I'm excited to be here with everyone. Thank you for joining. I'm Emily Freeman. I think about all things DevOps at AWS, and I'm joined by Benjot and Higgy. Do you want to introduce yourselves?
Sure, I'm Benjot Chinana. I lead the containers and serverless go-to-market team here at AWS.
Hi, and I'm Higgy Park. I'm a principal solutions architect focusing on serverless.
Fantastic. So yeah, we have containers representation, serverless representation. So I'm really excited to have this conversation and really just discuss the pros and cons of both and how they kind of create a Venn diagram. I think sometimes people are really interested in kind of discussing, well, containers versus serverless. And I've never seen it like that. Do you all agree, or what are your thoughts on that?
Yeah, for sure. When I work with customers, and I tend to work with some of the larger customers thinking about cloud native applications, and quite commonly you're going to see both of those. It's not like you're saying, it's not an either or, it's really more of an and. So for sure, I see that a lot with our customers.
Yeah, likewise. Usually it's customers starting on the journey when they're first kind of modernizing that first app, and they're trying to figure out, should I go serverless? Should I go containers? Should I try Lambda? Should I go to Fargate? Should I try EKS? And that's when they first ask about the containers or serverless. But I think quickly they get to the point of like, you've got to use both. There's capabilities in both that are useful. It depends on the workload. It depends on who's running the project and where that workload is going to end up.
So talk to me about that. Like how do you advise the customers you work with on what to choose and when? What are the differences between the workloads and where you should be running them?
Yeah, I think there's some really good patterns we've seen for where serverless really takes hold and can provide the best total cost of ownership. But I would actually start even further before the technical decision. I think there's a bunch of conversations that you need to have about whether you're actually driving your modernization initiatives based on a desire to reduce your operational load, or whether it's really about developer agility, or whether it's driven by security, or whether it's some combination of the three. And usually it's some combination, but then I think a key part of that question is who's gonna actually staff the resources for this application or that application, and where does that application end up in production? Is it going to be run by a development team, or is it going to be run primarily by an operations team who's trying to just standardize as much as they can across the application portfolio?
Okay, that makes sense.
Yeah, and I want to plus one the people side of things. Oftentimes people come with lots of different backgrounds and experiences. I'll have some customers who these are developers or architects that have been doing it for 20 years, and they say, I know how to do this. And they have a very particular opinionated approach to building applications. And so sometimes you may have to lean in one direction or the other, whereas you may have others who are a little bit more maybe lean forward and want to think about fresh and new ideas. And so a lot of those tendencies and leanings will allow you to make choices between one or the other. Now, certainly you can get really into the weeds and find technical nuances of why one will work versus one won't work, but we don't need to necessarily dive into those at this point.
Yeah, no, I think that's such a good point, because so much of any technical decision relies on the team that's available and the team that will be working on something, and the resources that a company can put into it. Even language choice is so much dependent on what languages the team already knows. And I feel like this fits that as well. There's a comfort level aspect to these decisions. That makes sense.
Yeah, it's an interesting point you bring up about language choice. I mean, containers and serverless are to some degree different kinds of languages you can speak, right? Containers really speaks to, I think, operators who want to find ways to, as quickly as they can replatform an application, and maybe the investment isn't necessary to go rewrite that application at any near term. Well, I think serverless really speaks to the developer side of the equation. It's really about how fast can you go and how quickly can you prototype and get that app into production and scale up and scale down. I mean, those are such huge benefits for both a development team and an operations team. But I think the technologies are almost like different languages depending on who's starting the conversation.
Absolutely. So oh, sorry, did I interrupt? No, I think a lot of times when we're talking about containers and serverless, we put it under the umbrella of a modern application or modern ops. What do you all define modern apps as? This modern application. What does it mean?
Yeah, maybe I'll take a first stab, and then I can let Manjot add to that. I think for me, the idea is we're trying to use kind of cloud native tooling as much as possible. So, here at AWS, we often talk about reducing the amount of work we do on undifferentiated heavy lifting. And so, again, for me, I tend to work with a lot of application architects and developers. And the idea being, give me the business requirements. What is it that we as a business need to go and deliver? And let's go build an application to do that and focus on building the application components, writing the code that delivers as directly as possible that business value versus, we're going to build a platform. And certainly platforms are incredibly important for large enterprises. But again, as we think about modern applications, we want to push more and more towards leveraging native services, managed services, so that we can focus our architect and developer time on building those customer delivering value.
Yeah, I love that description. I think the more you can leverage the cloud native capabilities, the less you're going to have to worry about. And I think for your modern app, for whether that app is written in Java or whether it's Python or whether it's the next latest language, I think it's important to figure out how much of that operational burden can you outsource, how much of it can you give away, and make sure you actually spend time on the things that matter.
Yeah, I think that's an excellent point, and it's something I think about a lot with DevOps and just operations in general. And moving to the cloud, operations has changed. It's still the skills can transfer, but it's different. And learning to operate at scale and in the cloud with these new cloud native applications, it's a different sort of approach to it. How do you all think that containers and serverless fit in? How do you abstract these operational concerns without sort of obfuscating concerns or hiding alerts, making sure that there's still visibility into the system?
Yeah, I think one of the things that we've seen customers do very quickly as they start to build out their next application is thinking about observability upfront, thinking about security upfront, building that in as opposed to doing it as a side project or an after effect of deploying the application in production and then realizing, oh wait, did we actually collect the logs out of this app, or did we actually put traces in so we can actually figure out what function calls are running slow? Like those things typically happen after the fact. One of the interesting things I've seen is customers, as they start to go down the journey of, hey, how am I going to build my next application, start thinking about all these things up front. So the operational concerns actually become not after effects, but really part of the application architecture. Mm-hmm. And then it takes a little bit more effort up front, but the benefits pay off dividends huge in the end.
Yeah, it's part of the architecture decisions in the beginning. Absolutely, I like that.
Yeah, and if I'll plus one that, and if I could add anything to that, it would be that it becomes this kind of this virtuous cycle, right? Because the architects and the developers are building the security aspects, the observability aspects into the application up front, it influences the direction of the application itself, right? Because they're performance sensitive or they're cost sensitive or they're security sensitive, they start to build their applications in what we would call well-architected manners, right? So they use these well-architected concepts to ensure that they're building cloud-native applications in a way that really abides by best practices across the different pillars that we would want to kind of analyze and evaluate our applications.
I think that's such a brilliant point, because so many companies really struggle, I think, on deciding what the priority is. Are we most concerned about performance? Are we most concerned about cost? And really kind of stating that up front is very powerful, but it's very difficult, you know. You have to choose.
Yeah, and I think, Emily, like you focus a lot in DevOps, and the great thing is that we can automate a lot of these considerations and capabilities, like when we're doing security scanning or even doing performance load testing. All of these things we can kind of automate so that maybe upfront there's a heavy lift to build some of the tool chains, or maybe the enterprise is providing them, or we're providing feedback into the enterprise tool chains. But at a certain point, maybe it's like one of those crawl, walk, run scenarios where initially there's a lot of upfront kind of human effort that we need to put into it. But over time, as the tools mature and as our application matures, we spend a little bit less time on that because now we've got a well-oiled machine.
That's amazing. And you mentioned the well-architected framework. This is something we talk about a lot at AWS, but do either of you want to discuss how that sort of fits in and how customers might be able to access it or use its information to make better decisions?
Yeah, I can touch on it. So I do. So one of the nice things is, I do focus on serverless. So well-architected reviews, there's really two components. The main core of the well-architected review is to talk broadly about your AWS adoption. So it will talk about how do you as an organization look at security. So it'll talk about a lot of it'll walk you through a number of questions, and you can talk to different personas and senior leaders at organizations to ensure that they're thinking holistically about their adoption. For me, a little bit selfishly, on the serverless side, we have different lenses. So for example, there's a serverless lens that has a subset of questions that pertain specifically to serverless. So we could think about, now you're building serverless applications with this serverless lens. Here are some questions that we can kind of dig into. What I've seen some customers do is they'll actually take the well-architected review process and then include that as part of their own internal operational processes. So as an example, I had one customer, they had a process that they called permit to operate and permit to build. Right? These were two phases or checkpoints that they needed to go through in order to, one, be permitted to build an application, and then later on, once the development phases have completed, they're now allowed to go into production. In that permit to operate process, they included the well-architected review to ensure that all of these concerns are considered before they actually go into production.
That's kind of fascinating. So probably things like security and testability and observability, all the abilities.
Yeah.
Fantastic. When people hear serverless and containers, and maybe they're working with legacy code and, legacy systems, is it too late to modernize? I mean, is this something only for greenfield applications that are brand new, or can everyone be a part of this?
It's definitely never too late to modernize. We have customers who are modernizing applications that are easily 30 or 40 years old, stuff that's sitting on mainframes. So yeah, and what's great about that, I mean, we think about it, but I mean, this is stuff that's running probably some of our most critical infrastructure, whether it's financial transactions or, whether it's the back-end customer database for most of our customers. I mean, this is where all the real information is sitting in these legacy apps. What's pretty amazing though is it doesn't have to be a path that's prescribed through, hey, let's first figure out how to re-platform the app or put it on a new operating system and then somehow make it turn it into a container and then somehow get it to serverless. We've had customers take the full leap and go from mainframe straight to serverless. And the hardest part of that journey was not actually learning serverless. It was actually making sure that they put a framework in place to make sure that they got the application right on the other side, right? It's the typical, like, we have to re-architect our app. Well, how do we make sure there's enough testability in there? How do we make sure we've got the right capabilities and features? How do we make sure the right interfaces are still available? And how do we find out all the other dependencies that matter? It's like typical work that you do for any application re-architecture.
Yes, which is always stressful. I mean, I've been on those teams and it's hard. So that's phenomenal. I did not realize that it would be that, I'm not saying it's seamless, but a sort of one step where you take this from mainframe to serverless on the cloud. What kind of concerns come up with that? And talk to me also, Higgy, maybe for you, how does serverless scale? Like, is there a point where serverless kind of hits a max, or is it infinite?
Yeah. I hear two questions there. Let me first talk about like concerns, right? And so, Banjo gave the example about, taking a mainframe application and jumping direct into serverless. I have a customer, I can't really name them quite yet, but I have a customer that we walk through that journey. And, part of there's kind of a broad range of concerns to think about. One is, before we talked about people, right? One is just enabling people to think serverless, right? If you're used to building a traditional 3-tier application, maybe it's just a 2-tier application sitting on monolith, so it's COBOL code with DB2 database sitting on a mainframe. And then they're traditionally now thinking about 3-tier Java applications using like Oracle databases as an example. First is just enabling the people to think, okay, what does an event-driven serverless architecture actually look like? What does that mean, right? So it might sound like a lot of vernacular, but that may not have a lot of applications. So part of it is just doing enablement, right? Let's do some training, enablement, help them kind of make the mental leap to think about how can we think about this business problem using a different paradigm of processing. So that's maybe one thing. And then the other thing is so that's part of working with the technology-oriented people. The other is then working with senior leadership, right? So they're going to be thinking, I have this mainframe application, it's mission critical and it's core to my business. You're going to go and do this thing called serverless, which I've never heard of. Like, to me, that sounds like risk, right? So part of it is then building business case and convincing them that actually this new architecture is more agile. We'll be able to meet your business demand. And actually, it's easier to troubleshoot the problems when they arise because we're going to, like we just talked about, build observability, build that monitoring and logging and troubleshooting capability into the application so that we can kind of do this in more near real time. Maybe now to your second question around scale and performance. So one of the nice things with when we think about serverless now, serverless has a number of different compute offerings. Like one of those is perhaps a well-known one, AWS Lambda. And Lambda will scale to meet your demand, right? So we have the capability, this idea of we're going to just run your function, and we have what we call these execution contexts in the background, and we can scale to thousands of concurrency per second. So we can allow you to just burst up very quickly. And likewise, when those execution contexts or execution environments are completed, they'll just go away, scale down. You don't pay for any unused compute.
I mean, let's just, from a compute standpoint, that is phenomenal. I mean, that is just unbelievable that not only do they not have to pay for whatever they don't use, but the effort required to build a system that can do that is just, I'm overwhelmed thinking about it, to be honest.
Yeah. If I could do one more plus one to that, one of the really big values that we see with our customers when we think about modernizing applications, applications don't exist within a vacuum. Right? Mm-hmm. Always applications are integrating with other either upstream or downstream systems.
You're right.
And really one of the powerful things about Lambda is that we have over 200 event sources that can trigger a Lambda function. So just a concrete example is I upload, let's say, a picture to S3. That can automatically trigger a Lambda function to be invoked. And let's suppose I want to automatically generate a thumbnail image as an example. Right? Traditionally, you might have a system where people SFTP files in, and then at night, they're going to run a batch job that goes and processes all those images that came in during the day, and maybe that batch runs for an hour. Now, in this new kind of event-driven model or event-driven world, we do these things in near real time. When the image comes in, we process it, and we go kind of along our way. And you can now imagine there's many, many, many use cases where we try to process these things in near real time, and that's where we have this kind of event-driven idea.
And it sounds like these events can happen concurrently, right? It's not like they get queued up. It's happening as it comes in for everything.
Yeah, so there's many different models in there, but yeah, we would just want to think about we're going to ingest a large bulk of messages or events, and then we want to process those as quickly as possible and in parallel.
Yes, okay. And you mentioned something interesting, which is, say a developer or a team, they're sort of pushing for this modern application, either containers or serverless or both, up to the leadership. I think a lot of times we talk about the business leaders or the CXOs making these decisions, but developers have a lot of power and a lot of influence. How could they best sort of sell or persuade this new paradigm to their leadership?
I'll throw in just a quick quick plug here. I think one of the best things you can do as a developer is to show the technology and show it off. The internal kind of viral adoption that happens is as powerful as, a CXO or a business leader getting on, getting in front of the team and saying, hey, we're going to standardize on this platform. I think in the last 10 years or so, we've seen developers just voting with their feet, right? They build on technologies that make sense to them. They build on technologies that are efficient, that take the operational burden away from them, that don't require them to have to think about how they're going to scale up or scale down or deal with cost or deal with security. As much of that as can be taken away. But I think it does require both sides. Like you need the development teams to buy in. And I think it's clear that once they've made a technical decision, you need someone to be the executive sponsor to come in and say, okay, we're going to make a bet and we're going to put budget behind this and we're going to actually train folks and we're going to help develop the center of excellence around either serverless or containers or whatever it is. And then we're going to help spread that out. And I think that's a critical part of getting the internal adoption, right? You've got to do some internal marketing. You've got to show off what you're doing. Otherwise, tree falls in the forest, nobody hears it.
Yeah, and kind of to build on what Banjo just said, also, one way, sometimes it's hard so the developers could get excited about a technology, but maybe the leadership isn't so much. And, I think what Banjo is maybe getting at is like, sometimes like what he had mentioned is you just build it and you demo it. But part of like what I do with some customers also is it's not just about building the proof of concept, but it's creating the story around it. So you can, here at Amazon, we're really big on data and metrics, right? So you can, as a developer or an architect, talk about, before with our old process, this would have taken us 3 months to build this capability. Hey, using containers and serverless, we actually built this in 2 weeks, right? And so you can kind of talk about the percentage reduction of people effort to be able to build the application. And then another way could be, we talked before about observability and maybe about troubleshooting problems that occur in the environment. You could also talk about, hey, in the past, these were some of our operational metrics around, mean time to recovery, mean time to resolving those issues. And then say, hey, actually, with these new observability tools, because we've built in performance and security into the application from the beginning, actually now we've reduced our mean time to recovery by 75%. So again, usually business leaders want to talk in those type of metrics. So we as technologists can actually help creating that story using those metrics. I think that's one way to help get internal leadership really on board to why we want to push more and more towards these modern apps.
Absolutely. And I talk a lot about that. You don't have to boil the ocean, right? We're not talking about making everything and shifting it over at one time. You can take small little services or small little segments of your application and test it out. And then, as you say, show this data off. I think also what's compelling for me, perhaps with serverless more so than containers a bit, is I think once you get past the misnomer of the name, you actually, I think it's a little bit more easy for non-technical leadership to understand. It's okay, something happens and then something else happens. It's event-driven architecture and approach. I think just makes sense intuitively to people, which really, really helps. From a leadership perspective, what's the best way to recruit? I mean, if we're moving toward this modernization and we need people who are more familiar with, and perhaps they're an AWS shop and they want things that are people who are familiar with AWS Lambda and Fargate and these specific services, what do you think the best way for them to approach recruitment and hiring is?
I actually think, at this point, it's super easy to train folks on this technology. I actually think it's hard to get folks from the outside and just, find new folks who are going to both learn your kind of culture of your organization, as well as learn your apps and, your app frameworks that you use, and then also somehow become experts on the technology. You can always find those experts out there. I think there are tons of folks out there who are training up on serverless technologies. But it's such an easy set of capabilities to learn. I actually think that's way more beneficial to the organization because it promotes retention. You get folks that are willing to stay on because they're getting skilled up and they're getting skills that they wouldn't have gotten somewhere else. Plus it helps kind of bring that change into the organization without being kind of a foreign antibody, like someone walking in saying, hey, I'm the expert on serverless. Let me teach you how everything works. I think it's great to build that muscle internally, and then you can bring folks from outside as well. And I'm sure there are plenty of folks out in the industry who can jump in.
Mm-hmm.
Yeah, I'll give kind of two ends of the spectrum in the story. I have a colleague who was here at AWS and recently went over to the customer side. And he was sharing this exact challenge, like, I'm here at let's just call it a pharmaceutical company. And, we're not known for being a technology company. We're known for being a pharmaceutical company, right?
Yeah.
But you want to hire strong technologists, right? And so he's, is currently faced with that challenge. I think some of the steps that he's taken is beginning to do public things that kind of show off their cases. So, one is creating public blog articles, starting to create maybe open sourcing some of their software that demonstrates some of their capabilities, and then maybe getting on webinars or perhaps participating in reInvent as a speaker and kind of showing off some of your technical capabilities to demonstrate that we as a company are now becoming more technology forward in thought. And then the kind of the other end of the spectrum, and I'm actually wearing their T-shirt from reInvent a couple of years ago, is Capital One, right? So Capital One, I remember I went to reInvent 5-6 years ago, and in the expo hall at reInvent is Capital One, and you're like, oh, that's interesting. Why is Capital One here? They're not really a partner or a vendor per se in the traditional sense, but they were very forward thinking and saying, we're not here necessarily to sell Capital One goods and products, but we're here to actually recruit and demonstrate that we're forward thinking. So one example is, Capital One, they open sourced their internal monitoring tool, which many people probably know as Cloud Custodian, right? And so it shows that as an organization, they're really forward thinking. They've committed to being all in on AWS. And even recently, they actually even talked about being serverless first, right? So really pushing the envelope in terms of building cloud native applications. And so again, I think you kind of see that spectrum of like, where do we begin? And now you kind of become like Capital One, where they're really pushing the envelope and people know that they're, really big on AWS and really big on being serverless.
I love that too, because, when you think of companies that would be slow to adopt, banks would be pretty high on my list, right? So the fact that Capital One is really leading the way, I think is phenomenal, especially in these newer technologies. I want to focus on containers for just a minute. Containers, Kubernetes, do they go hand in hand? Can they be separate? Talk to me. How do customers use it? Yeah.
Yeah, it's interesting. I think it used to be that you worried about first the container and then the orchestrator, and then there was like a myriad of opportunities for choosing an orchestrator. You can get Mesos, there was Swarm, there was Kubernetes, there was Consul and Nomad. I mean, there's a fantastic variety. I think we've all settled on the fact that Kubernetes is now the standard in terms of orchestration, and the container technology just kind of comes with it. But having said that, you don't have to spend your time managing orchestrators either, right? I think there are organizations that have said, hey, we're going to make a bet on Kubernetes because it is the standard, because we have a wide diversity of environments, multiple cloud providers. We run at the edge, we run on IoT devices, and we've got to standardize on some platform, and that platform requires orchestration. So, and that makes total sense. That means you have to go invest in the people and the technology and the training and all the other pieces to make sure you can support that. But I think for most organizations, you shouldn't have to worry about that. And so if you can take an approach where you don't have to think about the orchestrator, so technology like ECS, our Elastic Container Service, you never have to worry about what the orchestrator is doing. It's doing its job, and you never have to tune it or tweak it. You just tell it, hey, run this task, and give it the parameters for how you want to run the task, and off it goes. Scales up as needed. So, and then you add Fargate to that, and then you never even have to worry about the actual worker nodes that are running. Those nodes just show up, they get provisioned, they've got isolation in between your container tasks. You're good to go. So it doesn't have to be a doesn't have to be that you have to manage for both. They shouldn't have to be intertwined. So I think for most organizations, I would start with, think about if you're going to run something in containers, try to run it with the least amount of effort possible. Like start in the simplest way. And then, if you run a myriad of environments, if you're running across a variety of cloud providers, if you've got to standardize and you have the talent and the resources to fund a platform team that's going to be experts on Kubernetes, which you can absolutely do, then you go down that path. But I would only do that if you absolutely have to.
And I'm trying to think of use cases, but if someone wanted to start with ECS and then eventually move to Kubernetes and maybe utilize EKS, what's the transfer between those services? Is it pretty smooth, or what are the sort of gotchas?
Yeah, the big gotchas is learning how to manage Kubernetes, right? And for most folks, moving from ECS to EKS, your code is 100% portable, right? You bring your container images with you. You're going to have to rewrite your YAML and find a new way to describe it in the format that is the Kubernetes API, and that's not impossible, and it's not super hard, but it does take effort. So I think for organizations that are starting down the path, I would make a very clear choice. Like, is it worth your time and investment to invest in Kubernetes and having to manage that control plane, or can you get away from it? I would tell you that actually most of our largest customers run both. So depending on the workload, depending on the team that's managing that workload, depending on whether it's running in a production environment or whether it's more of an internal facing application, internal facing, non-production, but also largely managed by a development team, typically run on ECS and typically use Fargate as a result. Those that maybe you're running in production environments and have to run at scale and have to make sure that they can be 100% portable, have made a very clear choice on the type of workloads they have to run in a centralized platform, typically go to Kubernetes.
Okay. That's kind of amazing. And I think it highlights another point. We talk often as if these companies universally utilize X, Y, and Z, but it's really this team-specific, service-specific, even smaller applications within a broader context. The tools they use every day are going to be vastly different. And so a company could utilize all of it, but for very, very different reasons.
Yeah, I mean, back in the Stone Age, if we all recall, like we used to manage application by application, right? It was like you deployed your J2EE app on a specific OS with specific middleware on a specific hardware platform, and we had to manage that thing. Now at least we've got the benefits of, okay, we're all standardized on kind of virtual instances and virtual machines underneath, and if we can standardize on a container format, like we're way better than we were before, hopefully. But yeah, it does definitely take still some effort.
It was just, this is completely tangential, but it was just a few months ago that someone pointed out software, middleware, hardware.
Yeah.
So that was a moment for me. Oh, got it.
If I could add one tangent also, Manjot talked about like thinking about the container as an artifact. Actually back at the last reInvent, Lambda also announced support for container images as a deployment artifact for your Lambda function. So if we want to blow the lines a little bit more, certainly you can use your CI/CD pipeline so that your CI process is still building container images. They just happen to now be Lambda-based images. And then now your CD process, instead of targeting EKS, ECS, or Fargate, you can now just target Lambda as a deployment layer as well. So different options.
And that transition is probably easier than going from something to Kubernetes. So I would say, like, if you're going to move up abstractions rather than down.
Yes. I like that. Be a salmon. Move up abstractions.
That's right.
So we've talked about a few of these services, but what is the difference between Lambda and Fargate? And I'm sure, I know that there are many other serverless services. So tell me about the high points, please.
Yeah, I guess for me at least, the big key thing to think about, and this is more I'm putting on like the architect hat of like why would I want to choose one versus the other, and oftentimes it's thinking about an event-driven paradigm versus like I need a server or I need a process to be running at all times. So for example, if I want to run an Apache Tomcat server and have host an API through there, or I'm going to run a Spring Boot application to host REST APIs. Those type of application models or frameworks expect the process to stay online and act as the server. Alternatively, if we want to say, I want to move away from Spring Boot, and I just want some managed service to be the API layer, and then the API layer will then just make some function calls and run whatever compute on the back end. I think that's where we start to transition a little bit. Again, this is pulling away some of those common infrastructure elements, using a managed service, and then focusing really on just building, the business logic associated with, in this case, like a REST API. To me, that would be like, at least from an architecture standpoint, like where I always start to distinguish the two. They both work, and they're both completely viable alternatives. I think a lot of it depends on, as an organization, which paradigm do you want to choose? Do you kind of want to, maybe you're very used to Spring Boot and that's how you build your applications. And I think you continue that way, especially if you have a lot of operational maturity in that way. But maybe you'll have some tighter teams in your organization that are saying, it's fine, we love it. And the majority of our applications will be like that, but let's just think about something new, see if we can make it a little bit more efficient, or maybe reduce some of the work required to get this product launched.
That makes sense. Does cost factor in with this? I mean, when we're making decisions, and I guess perhaps broader, what are some of the anti-patterns you see as people kind of think about these things? But I would be curious, like what are the decisions they have to make, and how are they kind of approaching these?
Yeah, I think for cost structures, look, at the end of the day, I think Lambda is the cheapest and easiest way to get started on any application, right? Like anyone who's worked with Lambda knows that you can get started really, really quickly. I think if you're trying to manage your costs as you scale up, I think that's something you have to do very consciously, both in containers and serverless. I don't think there's a huge difference there, except that in containers you're bound a little bit more by the resources, depending on whether you're using Fargate or whether you're managing instances in your worker groups or not. But I think that's a place where as you move up that abstraction, that's something that I think comes to the forefront for anyone writing their application. You have to think about what that's going to look like as you scale up. How important is it for you to be able to service every request that comes in, and how popular is this thing going to get? So I think it's an important thing to consider as you start developing your application architecture. But to get started, I think it's a no-brainer. You always start with Lambda.
Okay.
Yeah, and because I guess I'm on the serverless Lambda side, and I kind of know some of the pitfalls, I will say that when it comes to cost, especially with Lambda, abiding by architectural best practices is really a big deal when you want to optimize on costs. So there are certain anti-patterns with Lambda, or maybe there's certain developer practices that we would strongly recommend against. And you could almost shoot yourself in the foot if you kind of use Lambda functions in a wrong way, where you could actually incur significantly more cost than if you were to use maybe a container-based solution. I'll just give one example of just ways to think about, before we were talking even about observability, and we could talk about how observability ties into cost. I had one customer scenario where they had some downstream dependencies that broke within their infrastructure. And, instead of using observability metrics and trying to determine the root cause that way, they kind of use the traditional model of, I'm just going to throw more hardware at it. And with Lambda, the way you throw more hardware at it is you can either increase the memory associated with your function, or you could just increase the concurrency associated to the function. So in their case, they said, I'm just going to throw both of those at the problem and see if we could resolve the problem. Unfortunately, it didn't. And it then caused costs to increase as a result. So again, these are like anti-patterns. So we want to ensure that all of those best practices are built in, and therefore we can then realize kind of those cost savings. So while I would love to stand here and say serverless or Lambda is always cheaper, that's not always the case. We want to ensure that we're applying those best practices.
Yeah. You bring up an interesting point in that, I think as things get more and more abstracted, we think that I think there's a chance that people assume that the skills of, 30, 20, 10 years ago don't apply anymore. But really, these trade-offs are the same. You're still thinking about, do I want it fast? Do I want it cost effective? Do I concurrency versus memory? Like how do we think about these things? And I think the fact that the principles and the baseline knowledge carry through is really important.
Yeah, it's really. Sorry, go ahead, Iggy.
No, I was just going to say before we talked about well-architected, and I think this is one of those scenarios where we just do a well-architected review and we can kind of talk through, here's the architecture, here are some of the things you've done very well, here are some things that perhaps could use some improvement and help you operationally and on costs.
Yeah, I was going to just add, I think it's, it's interesting as we see more and more customers scale up, that cost allocation as much as cost management becomes part of how they deal with the kind of growth of their application portfolio, how they deal with, independent, businesses, independent teams, using a shared platform. We've seen for a lot of customers, it's not necessarily that they're trying to reduce their costs, but they're trying to make sure those costs are used, the resources are used efficiently. And the more you put on either a shared platform or into a cloud native service and someone else is getting the bill, the less you have to worry about the cost. And so, we go back to maybe those days of mainframe where you have to do cost allocation. You have to show someone, how much they've spent in order for them to understand whether they can do things more efficiently and drive the right behavior. And I think that becomes important in both leveraging kind of cloud native services, but also if you start deploying on a common platform. So if you end up, putting out a single container platform for all of your teams to use, you've got to build in not just cost management for your platform team, but also cost allocation. So your dependent teams know what they're doing on the platform as well.
I think that's such a good point. I make fun a lot of what I call the blank ops. We had DevOps, and then we got DevSecOps, and then we really went off the rails with ML ops and AI ops and all these ops. But this is where FinOps, I think, really comes in, and that's sort of the focus of it, is trying to just be aware and conscious of your spend and how it impacts things. Let's see, when people talk about serverless first and serverless first strategies, what do they mean?
Yeah, I'll take that one first. Let me start with what serverless first is not. Serverless first is not serverless only, right? And so I think before we talked about, is Lambda or containers, is it either or? But again, I think we can start to realize it is an and idea. So when we talk about serverless first, it's thinking about a problem through the lens of serverless capabilities. And again, within the serverless portfolio, we have a broad spectrum, right? Within the compute layer, there's AWS Lambda, and then there's also Fargate for containers. We have different storage serverless capabilities like S3, which is our object store, DynamoDB, which is our NoSQL database. And then there's also Aurora serverless, which is our relational serverless capability. And then there's another layer, which is like our integration services. So things like API Gateway, SNS, or Simple Notification Service, SQS, or Simple Queue Service, AWS Step Functions, right? So when we think about serverless, it's kind of what we talked about before of when I have a business requirement, I want to think about building it cloud native, using native services, building it kind of as a modern application. Again, the code is really focused on driving that business value. So again, if we can architecturally think of it that way and satisfy the requirements with those capabilities, then by all means, let's architect and build in that fashion. Now, again, we did talk about there are anti-patterns or maybe practices that wouldn't necessarily merit, for example, using AWS Lambda as the compute platform. And then maybe we have a tiering of, okay, we're going to now use Fargate. We're going to determine if now we're going to build this application as a long-lived process, but we still want to use a serverless capability. It just happens to be deployed as a container. And then, of course, maybe there's a scenario or a reason as an organization that doesn't work, and then maybe you'll use some other offering. So it's kind of having this tiered effect where we start with those capabilities, and then based on requirements, maybe we have to go down to a different offering.
I think that makes a lot of sense. I saw the State of Serverless report by Datadog. They found that 80% of containers customers are also using Lambda. So clear.
It's an amazing common paradigm now that, and I think people forget that you can't run everything in a container. You can't run everything in Lambda. So you have to use
what? This heresy.
How did that work? How did that happen? I will say that I liked Higgy's description of serverless because it includes such a wide variety of capabilities that can also be used alongside containers. Like surprisingly, you can use Event Bridge, you can use API Gateway, you can use all of these integration points alongside your container platform as well. Now it's interesting in the operations world, we also say, hey, Fargate and technologies like that are also serverless technologies, but I would put those in the category of serverless ops, right? If you're really trying to not manage infrastructure, then Fargate is the model you want. And I don't know if it's a misnomer, but as a part of the serverless offerings, I think it's really more about serverless operations than it is about developing an event-driven architecture or developing an application stack that is built off of Lambda. We have a new offering actually that just came out this year called App Runner, which blurs the line completely between containers and Lambda and serverless, and provides just a really simple way to deploy a front-end web app. It's just super simple. All of your load balancing and all the deployment is taken care of for you, and so kind of sits right in the middle of that kind of serverless set of capabilities. And I think we're going to see more of those. I think where we can provide interfaces for customers to just say, hey, I'm trying to deploy a batch application, or I'm trying to deploy web front end. Here's the interface for you, right? Make it as simple as possible, and then they'll be supporting technologies around that, whether that is Event Bridge, or whether it's Lambda, or whether it's Fargate or containers.
I think we just had the invention of another blank ops, serverless ops. So you here today, we have found that.
We've added one more.
Just one more, add it to the pile. At this point, who cares? No, it's an interesting way of thinking about that. I like that sort of delineation. I think one of the interesting things about how tech is shifting is, I've been talking about personas versus roles, and my whole thesis is that personas are immutable. I was a developer. I'm always going to identify as a developer, even if I'm participating in activities that belong to other personas. And so how do these things kind of shift and move in modern applications? I feel like, developers are doing more operations work than ever before. What have you seen in customers that works really well as far as, and then tangentially to that, how do the titles track? I feel like titles right now are just all over the place.
Yeah, I'll take a first stab at that. I do see there's a broad spectrum of, this is Conway's law around organization defines architecture. And so you do see some traditional organizations that have separate operations teams, separate development teams, and they're trying to be, in a way, bimodal, where they have that, but also they're trying to, AWS, Amazon, we came up with this idea of two-pizza teams some time ago. But the basic idea is you have a small number of people that could be fed by two pizzas. And again, there's a lot of memes out there about what that actually means. But
I know, I'm like, New York pizza, deep dish, what?
How big is that pizza?
Yeah.
The teams are cross-functional, and Emily, I think that's what you're kind of getting at, right? Is you have architects, you have developers, you have SREs, site reliability engineers, you have security people, you have product owners, all operating within the same team, and all of the concerns with that product that you're trying to deliver for your customers are all owned by that one team. Whereas, So, there's kind of different spectrums. I've also worked with large enterprise customers that don't want to move into that model because maybe they're not really comfortable with that and they're used to the traditional model of having a completely separate operations team, the different product and development teams, and then maybe they'll have things like some type of cloud center of excellence or some type of central teams that are kind of oversight roles, but not necessarily these different small two-pizza teams. So there is a spectrum of adoption. I think a lot of this will depend on comfort of senior leadership for kind of really pushing the envelope organizationally versus we're going to kind of take baby steps, again, like the crawl, walk, run, and we're going to kind of slowly move into that model. I think for those people who've read the Phoenix Project, I think that's a really good book that talks about, the journey of a fictitious company that took that model of let's crawl, walk, run into a model of moving more and more towards DevOps.
I love that.
Yeah, I'm going to go out there and say, I think we're all becoming developers. Let's face it, like everything is getting written as code. Infrastructure is code. Applications are obviously written by code. Now there's security policy as code. There's, a variety of new ways to basically make sure that everything that everyone does is written in a structured format that they can store in a Git repo and then use a DevOps pipeline to just manage the deployment of. I mean, I think we're all getting there. I remember talking to, this was the CTO of Chef back in 2014, or maybe it was 2013. And he said to me, look, I think we're all just developers. Some of us are just, developers on different languages, and some are better than others. But I think we're, at the end of the day, all just becoming developers. And I think that speaks to kind of where the industry is headed, where we are going to have our own languages, we're going to have our own interfaces, but we're all going to be writing code to some degree.
Even if it's YAML.
Even if it's YAML.
Which, bless you, my YAML people. In the last few minutes, I kind of want to put on our futurist thought leader hats and think about what's sort of next. How are these two sort of paradigms really leading the way on how companies think about this, but also how does this fit into the whole narrative around centralizing, decentralizing? If anyone wants to take a stab at Web3 or whatever that means, we can go there. But yeah, I'd love your thoughts about the future of tech and how this fits in.
Yeah, I'll take a first stab. I am by no means a thought leader, so I will throw out there what I think will happen in the next maybe 3 or 4 years. I don't know if I can go 5 or 10 years out, but
I don't think anyone can. And if they
so it's interesting. I think organizations, are going to become more decentralized. So as the patterns for application deployments, as the patterns for how we develop new applications or modernize and refactor and replatform just become more innate to how we do business, we're going to get used to refactoring all the time, right? I think we're all trying to get there, and we're all trying to make sure that, we don't get stuck in, what happened 30 or 40 years ago where we built once and, we held on to it forever. And it was, we were server hugging and, we were holding on to our mainframes for 40 years and hoping we'd never have to change anything. I think we're all realizing we're always going to have to change. And that's what the industry has moved towards, which means I think we'll start to decentralize a lot of the responsibility for operationalizing that change. And we'll also start to decentralize the ownership of what happens when we make those changes. So I think we're going to see, as you pointed out, I think the roles are going to blur, and the persona of I'm a developer will mean I develop in the morning and then I deploy to production and I do monitoring in the evening, and I'll take a page during the weekend. And I think everyone's going to get in that same motion. I think infrastructure operators who run container platforms are getting used to the fact that, hey, Kubernetes deploys a new version or releases a new version 3 times a year. You have to upgrade your cluster, so you're also deploying changes constantly, whether it's the cluster or whether it's all the sidecars or the third-party operators that you're deploying inside your cluster. It's just a fact of life now. So I feel like that's going to help us decentralize. I feel like that's going to lead to a better outcome where we're managing that change more effectively and efficiently. But I think it also forces us to think about how to move up those abstractions. So I feel like if I could say, like, I think Lambda is the future. I think serverless and capabilities like Lambda or App Runner or batch running on top of containers, I think that's what the future looks like. And hopefully we're going to be managing a lot less infrastructure in the years to come.
Yeah, I'll add to what Banjot said. I'll put on an architect hat and think about it in a little bit of a different axis. I spend a lot of time in my kind of day-to-day job thinking about use cases. Like, what are the things that our customers are building? And I think about it along different industry verticals. And depending on the industry vertical, your needs may be very different, right? And so when we think about centralized versus decentralized, I'm going to think about it more in terms of architectural computing. There are going to be use cases and scenarios where it makes sense to have a centralized computing model, but then there are going to be others that it makes sense to have a decentralized computing model. So like an example of centralized computing, this is an area of research that I spend a lot of time on, is around doing large-scale data processing with Lambda, as an example. Most people will look at Lambda and think, hey, wait a minute, it's got a 15-minute timeout limit. How are you going to do large-scale data processing?
Yeah.
Well, there are different ways to think about it, right? So when you think about, like, I'm going to run an EMR or a Hadoop cluster, and I want to process a petabyte of data, right? In that Hadoop cluster, typically you're going to read that from some type of HDFS layer, read it all into memory. And again, this is across a very large cluster, and then do, let's say, a Spark job to do all the in-memory processing, right? Now, certainly Lambda can't load all that data into memory, and it's not going to be able to do that within 15 minutes. But if you think about it and you say, can I attack the problem a little bit differently, right? So if I can break up the data into smaller chunks, let's say I do it in 1 million 1 gig chunks, as an example. Now I can take that 1 gig chunk, ingest it into Lambda, and quite possibly process it into within the 15-minute timeout. So there's concepts, things that I've been researching and doing some work on in terms of thinking about, can I do serverless MapReduce? Again, this would be kind of like a centralized compute model, but using the MapReduce framework and using Lambda as the compute, underlying compute. Sorry, go ahead.
No, I think it's amazing. I was just going to comment that I'm having, technical interview memories come flooding back about. It's like, how do you solve this massive thing? And
right.
break it into
so I will caveat, it is an area of research. I've helped one customer actually implement and build it, and I continue to think through some of the implications of that. But then on the flip side, like the decentralized side, I have other cases like in the automotive segment where you think about, I want to do edge compute or ML inference. When you think about like self-driving vehicles or software-defined vehicles, sometimes you need compute to run in the car, right? So unfortunately, Lambda can't help you there. So you're probably going to run a container in the car. If you can have some type of orchestration platform or runner within the car or the vehicle, now I can do inference. So now all of that computer vision, the models that you wrote, you could deploy into those edge devices. Or you have other scenarios where you have manufacturing facilities and you want to ensure that the machines and the equipment are up to snuff. So they're going to emit telemetry data. Maybe you have some type of edge collection device, and then maybe you're going to do inference at the edge. So there can be models where you're going to be doing a lot of compute at the edge, but even in that model, you may bring some of that back, maybe do inference kind of within this center. So this is one of those things, at least from an architectural standpoint, from a computing standpoint, you can see both. You're going to see, depending on the use case, you'll see some of it centralized, some of it decentralized.
Yeah, absolutely. And, I hear edge computing thrown around. What does it mean?
To me, it's just the ability to take your compute closer to where your data is starting its journey, right? So where you're collecting your data, where you can bring analysis closer to that point. To me, that's what it is. But it could be devices, it could just be remote data centers, it could be retail locations. I think we've got really great examples of customers who live in a completely edge dominated environment. In retail, you have nothing but, stores or retail locations where most of your compute happens. That's where your point of sale happens. That's where your transactions are processed. That's where the credit cards are processed. And central compute doesn't, it provides the back end for all of that, but you don't function unless your retail store is up and running. So to me, that's a perfect example of what edge looks like. I think we'll just see more of those. I think we'll try to push edge. We'll try to push compute even farther out to the edge. As Higgy was pointing out, when you want autonomous vehicles, we're going to have to push compute out onto the car somehow. And we've got faster and faster processors coming out on those cars and devices connected to those cars.
It's wild to me to think that eventually I will take my car in and they'll have to repair the container that operates in it. Like, that is just, we're not talking about catalytic converters anymore. We're talking about containers in my car.
And that's just tell you to reboot your car.
Yeah. Have you rebooted? Have you let the energy drain out? Can't wait. That sounds like a blast. This whole conversation has been fascinating. I just want to thank you both for joining me and answering all these questions for folks. I hope it's been helpful for everyone watching. Thank you so much.
Thank you, Emily.